We're really happy to be here to our third Urban Thinker Campus panel. We're really excited to have you all here. Today, our subject is going to be Earth observation approaches from informal settlements mapping. We have the four people that are part of this collaboration: Monica, Anthony, and Julio, and myself, Jota, who I'm going to lead this first part just to give you a little bit of idea of what's going to happen. Julio is going to do a little bit of introductions about the context of what are we talking today. Then we are going to have two presentations, one by ID Tatum and another one by Rain Vargas Mareto. We'll follow up by a series of roundtable questions with members of the panel and members here present who will be able to discuss. And then Anthony will give us closing remarks about the entire event. We're very excited about it. We want your participation, and for that we have created this mirror board where you can use your cell phone to log in there. I will also put in the chat the link so you could access the information and you could give us here. Basically, what we want to in this board is put some information about yourself, your name, and maybe links and emails that others could contact you. We're also going to be in real time putting notes about the presenters' panels. And finally, you could ask questions directly on the mirror board. And this will help to populate the discussion for the roundtable, but also will keep the mirror board alive after the meeting, so everybody could come back and continue the conversation beyond the space of this panel. Again, thank you so much. And I'm going to give the floor to Julio.
Thank you, Jota, and thank you for all the people present in the meeting for joining us. So I will just give you a brief introduction about the things we're going to talk about today. So basically, we are living in a massive urban age, considering the days we are living in. And there are forecasts expecting about 70% of the total global population living in urban areas by 2015. But we are not often seeing that majority of this population increase is expected to be happening in low and middle income countries. But we are always, or mainly thinking in the big cities like Mumbai, Jakarta, Nairobi, São Paulo, Rio de Janeiro, and many others all around the world. But what is strong in this picture is that also the majority of this urban population is expected to happen particularly in the secondary cities. And the thing is, we know very little about what is happening there in this secondary cities. So besides that, we have also some challenges from a conceptual perspective. So are very confusing terminologies when we are talking about slums, often relating it to the United Nations Habitat definitions. Slum household concept, it's a more local concept, and a group of slum households form a slum area in a more area level definition. And we call it some kind of informal settlements, that it's defined by some sort of irregularity and many other factors that I cannot go so deep inside it at this point, but we have been labeling it as at least the private urban areas, both at the household level and also at the area level of the informal settlements. We can go to the next, please, Jota. But what we see in many cities around the world, it's both in high-income countries and low-income countries, but of course, particularly in low-income countries, we have massive inequalities going on, which is frequently in the media about its connection with crisis, conflicts, environmental crises, and different environmental conditions, but also related to morphology, which there's hardly open spaces, no green spaces for people to have interaction. But also when we talk about inequalities, we need to acknowledge the massive assets that exist in these areas. And in the picture here, that are often overlooked. In the picture here, you can see some kind of community library built in informal settlement. So we need to consider the inequalities, but also the assets that have been built inside the communities in order to discuss in a more deep way. Can you go to the next, please? Okay. So this is a recent example by Professor Monica Kufer that is here in the meeting, and also Dennis Yuwankin from UN Habitat. This picture is a part of Nairobi. I think it's an informal settlement, a huge informal settlement, and known as Kibera. Is one of the largest African informal settlements that we know of. And from this GIS perspective, this is a very good example where they map together with the community groups within the area the location of the trash piles, which is actually a massive environmental issue there, not only because of the pollution, but also because of its contribution to floods, because the trash pile often blocks all the drainage system, and after the flood, all this waste, it's flowing into the environment and in the local, and it has lots of different and direct impacts on the health of the people. And as Professor Monica said at some point, particularly when you look at the children playing in the area, and as a result, we have a massive issues related to the waterborne disease. So this is some idea, the information we don't have about slums and about the informal settlements, and then it's are particularly important and depend on the perspective that we look at. Next slide, please, Håkan. So this is just another example for an informal settlement, this time in Brazil. It's called Favela do Banhado. This is located in a city called São José dos Campos, a very wealthy city, actually. And the Favela do Banhado was threatened with forced removal countless times in its more than 100 years of history. It's a very old favela, and it's informal settlement in Brazil. And because of it, because it's occupying a highly valued central area in the city of São José dos Campos. In this case, particularly, the community, with the support of the university and the public defender's office, create a kind of a detailed map of their informal settlement where they live in at the household level. So it's because they never have an official map. The government never actually built an official map of the area. It's always a huge gap in the official maps for over 100 years. And this map pointing out lots of their assets, because there are a lot of good things there, but also the problems, and the problems they look in how to solve it, proposing some viable solutions. And from this kind of GIS approach and community mapping together gave rise to what we call there the popular plan for regularization of the area. And it has so far prevented the removal of the families and their affective ties from there. This is another example where the information about slum that it's missing, it's something that can help solve different problems, or at least to see some future for these areas. Next, please, Jota. But on the top of all of it, I would like to add one more layer of complexity, if I say so. Connecting the informal settlement data we need to produce to the ongoing climate change issues that we are facing. So, well, we know that the urban population will increase a lot. There's this forecasting that I talked in the beginning, most of it in low and middle income countries, and it will be beyond the largest cities, as we know. So having data to understand how this urban growth process is happening is a key point, and we need it more than ever. This is an example in Brazil. As you can see, it's just showing a kind of model that showing how the urbanized area have occupied in the last 38 years, from 1985 to 2022, the valley bottoms and flood-prone areas. And in this case, we derived these flood-prone areas using a model called PAN. And this is the kind of maps that we are producing in Brazil to see how the urban areas are occupying the flood-prone areas. Next, please, Jota. But from that, what we estimate is that between this in 85 and 2022, Each of 100 hectares occupied by Brazilian urbanized areas, 11.5 of them were in the flood-prone areas. But if you look just in the case of the informal settlements that we have mapped in Brazil, about 30,000 of them, for each 100 hectares, there's a 17.3%, 7.3 of them were in flood-prone areas, which of course raises a lot of questions on how these complex urban areas will be disproportionately affected in face of climate change. And this is just an example from Brazil, and it can be, we can think about it in different places of the world. And next, please, Rota. So this is the thing about the missing data, right? An example in conflict areas here, also from Professor Monica Kuffert. In this case, the conflicts like in the Gaza situation that we are facing now, seen in the medias, but this is an example from Khartoum. Because of the conflict, it's an almost forgotten conflict. They start earlier these days. We are looking at a viewer's image that it's nightlight images. Basically, it reflects how a large part of the city basically disappear over a very short period of time. And this image shows us reflects the electricity access, but also water supply access and a lot of other things that are usually connected to the electricity. And we can see that we don't have data about that, because in this case it's a conflict zone, so we cannot enter in these places. But the thing is that this kind of stuff, we don't have data about the place. It's not limited to conflict zones like this one. This is just an example. Also in irregular areas, particularly in the slums and informal settlements, that is the things that we are discussing here, there are massively missing data. So missing data about its morphology, but also typically about for their population counts, for example. And so the missing data is a hot topic today, and is an important one for our meeting. And this is why our presenters will give some state-of-art examples of using Earth observation and artificial intelligence to generate the data that we need for thinking about the seeds that we want to see in the future. And this is a very brief introduction. I will give back the word to Rota to introduce our presenters, and thank you very much.
Thank you, Julio. That was a difficult thing to produce and to present. Thank you so much for that. So you sort of knows right now, and now we go and have the opportunity to present our first presenter, Andrew Tatham. Professor Tatham is a professor of spatial demography and epidemiology at the University of Southampton, and is the director of Worldpop. Leading a group of 30 researchers and data scientists, he's interested in how populations, their characteristics, and their dynamics can be mapped at high resolution across low and middle income countries. His research has led to pioneering approaches to the use and integration of satellite, surveys, cell phone, and census data to map the distributions and movement patterns of vulnerable populations for disease, disaster, and development applications. He runs international collaborations with national governments, UN agencies, and data providers, and leads multiple research and operational projects funded by the Bill and Melinda Gates Foundation, Wellcome Trust, World Bank, GABI, Clinton Health Access Initiative, and others. And with that, thank you, Andrew, for being here. Looking forward to the presentation.
Thank you. Yeah, thank you for inviting me. So in 10 minutes, I'm going to give a kind of flying overview of some thoughts around, in this case, I'm focusing on national, regional, and global population mapping. So perhaps not the focus on a single city or a single informal settlement, but thinking about ways to map populations across entire countries, entire regions, and globally, and trying as best as we can to capture those urban populations and the informal settlements within them. And I'm not going to say I have a solution here, but this is just ongoing research, of course. So firstly, I I think you know this. What's the use of small area demographic data? It underlies all kinds of governance, setting strategies, health metrics, taxation, land use, really valuable data, and often is not available at small area scales, not available in recent times, real challenges with getting that kind of data. What we're aiming for in Worldpop and many other groups is to try and produce estimates at grid square scales of those population distributions. That doesn't mean we're going to be perfectly accurate and know that exactly that there are 8.6 people in one grid cell. But the value of having these kinds of data at these small area scales is its flexibility to be able to aggregate to different types of units, whether it's administrative units, health units, define a settlement extent and estimate populations within it, or define an informal settlement area and estimate populations within it. Integrate with data on health facilities, the location of polling booths for planning elections, all kinds of approaches and uses of these kinds of data. And then the type of approaches to produce such data, there are different ingredients. Obviously, some form of population data, some form of settlement data that tells us where people are not living and where they are, and then some form of covariates that help us understand within those settlements how the population density is varying. Those all come together in some form of statistical model to produce population estimates at those grid square scales, ideally with some form of confidence intervals, uncertainty metrics around them. So I'm not going to have time to talk really about the methods to do that. So the first component, this settlement, I was looking back at a paper I wrote a long time ago before my hair was more gray. This is 2005, and this is the kind of state of the art of mapping settlements, in this case, from satellite imagery for Kenya. This is Nairobi, the outline, and it was it's quite amazing how far we've come. Then we were able to really take AVHRR images or MODIS images, map a blob, and have very little variation across the city. Of course, now we're at the stage of data sets like World Settlement Footprint, Global Human Settlement Layer, that are mapping down to very small scales consistently across the globe. Not perfectly, of course. And of course, we also have the types of data set you showed in the introduction, where we have different efforts to try and map building footprints across large scales. Again, not perfect, and we have a range of work trying to compare the gaps and differences between them. So that settlement data helps us identify where people are likely to be and where they're not. This covariates then help us understand how those populations might vary. And the aim here is to really try and build up a picture of the landscape. We can't go and count everyone everywhere at every time point. It may be possible in a census, but often these types of populations we're interested in can be missed in censuses. So we're trying to understand, what does the landscape look like? What can we capture about that landscape from Earth observation, from other geospatial data sets that can help us characterize those types of variations that exist in urban areas as best as possible, so that we can use that to predict and estimate populations within urban areas accurately. And these kinds of data can come from, as I've said already, the building footprints, but also extracting extra information from those. So looking at the densities, counts, lengths, variances within areas gives us some indication of how dense buildings are in an area. We can look at the patterns of those buildings, identify certain types of patterns that correspond potentially to certain types of neighborhoods. We can train computer vision algorithms to recognize those. We can also train computer algorithms and AI nowadays to recognize different types of building, whether those are residential or non-residential. And then there are a whole range of other data sets that are just popping up all over the place. Estimates of building heights, more detailed images of the Earth at night. Now satellites up there measuring the heat of an area at high spatial resolution. There are, of course, incredible data sets now on road networks, infrastructure, the location of marketplaces, health facilities, and there are data sets coming from digital devices, whether it's smartphones or standard phones, and looking at the density of those and characteristics of the patterns, the calling patterns of different areas. And a plug for the next talk, hopefully, there are great sets of data coming from initiatives like Ideatlas. So then we bring it all together in some form of spatial statistical model to try and predict those population estimates. And there are two broad forms of those types of model. Firstly, the top-down approach, where we have population counts at an aggregate level that we are confident in, that represent those populations we're trying to map, and we're trying to build a model to disaggregate those to grid squares. The alternative approach is a bottom-up one that I'll talk about in a minute. But firstly, this top-down approach. And obviously, if you have incredibly detailed census data like exists in the US, where each one of those census blocks can sometimes be smaller than 100 by 100 meter grid square, this type of modeling is perhaps not so needed. It doesn't make a big difference that you're trying to distribute populations when you already have a very detailed picture of the population. But where it can be of value is perhaps situations like this. This is Kinshasa in Democratic Republic of Congo. We may only have units, about 20 units that cover the entire city, and an interest in knowing much smaller area distributions. And of course, over the years, our ability to map those population densities, the range that exists across the world, across countries, is getting better. We're thinking now here about there are some areas that are incredibly sparsely populated. This is a photo I took last week from a plane coming into Lilongwe. But what we're really interested in this talk is this incredibly high population density end, the top end of the spectrum. And over the years, in terms of methods, they have improved to perhaps capture more and more of this distribution. So if we think about a very simple approach of just spreading population equally within those census units, we may have on the top left here, census unit A has 8,000 people and B has 16,000, and we just spread them equally. We produce a gridded population data set, but it probably only captures that mid-range of those population density ranges that exist in an area or a country. We're not really getting the really high density populations or the really low ones. Then there are decimetric type approaches, which are getting better and better in correlation with the availability of building footprints of really detailed population settlement data. And this enables us to then distribute those populations in relation to those buildings, and again, capture a bit more of that spectrum. And then there are the more complex approaches that make use of stacks of geospatial covariates to try and capture within settlements as ranges of features that exist, and hopefully, although probably not perfectly, still trying to get to the ends of those distributions. If we can capture the characteristics of an informal settlement or slum area, we can hopefully be able to then predict better in those places where we don't have population data. So just looking at how these kind of approaches look, we can see this is again Kinshasa. This is how it looks when you spread population equally from gridded population of the world. This is the global human settlement layer population, which primarily uses just the GHSL settlement layer. This is the Facebook high resolution population data set. And this is the Worldpop one, which uses a bigger range of covariates and therefore capturing more variation. Whether any of these is most accurate is tricky to know without some validation data, but it shows the range that can exist for these different types of data being used. An important question to add in is, as I think we talked about in the introduction, some of these census data sets just do not capture populations residing in informal settlements. So we already have a problem if we're just taking this data and disaggregating them to grid squares. We're still missing those populations. And some of this data is also very old. For many of these countries, the last census could have been 10, 20 years ago. So what can we do if that input census data are rubbish or problematic, especially in terms of informal settlements? This is where more recently we've been exploring these bottom-up modeling approaches for situations where we don't trust the aggregate data, where the census is outdated or doesn't capture certain types of populations. And here we are trying to make use of counts of populations in smaller areas that may be easier to collect or may exist through household surveys, and then training a model to predict into the unsampled areas. So we may have a situation where we have population data in the brown area and nothing in the yellow area. So we're trying to fill some small gaps that may have occurred in a census. Or we have the situation where we have small area data from surveys, from microcensus samples, surveys, but we're trying to fill in a much bigger area. What we do have across that entire area, of course, is a set of geospatial covariates again. The number of compounds, areas settled, vegetation indices, perhaps a stack of about 50 of those, depending on what is available. And what we're trying to do then is look at the relationships of where we do have population data in those sample areas and the geospatial covariates. So we may have some relationship that exists between building density and population density, between night lights and population density, but these are often very messy and uncertain. But when they come together across a range of data sets and we account for some of the spatial variations that exist and quantify that uncertainty, we do have a way of producing predictions and also providing confidence intervals around those. So these tend to look a bit more like this, and this is about as complex as I'm going to get. This is a model that was used for the Democratic Republic of Congo, one area of that country. And important part of these types of models is this hierarchical structure, so that we can account for the fact that there may be different relationships between the covariates and the population by province, by region, by local area, and also by settlement type. So that where we do have data on settlement types, in this case, there's an example from northern Nigeria where different settlement types were identified and then manually mapped and used as a way to design samples. And again, another example here of trying to automate this approach a bit more, where we're using those geospatial data sets to actually identify and stratify a city and then use that to select samples so that the model is exposed and has available to it a range of data that represent the range of conditions that exist in the city. So we're not just taking samples from the rich area and using that to predict populations, but we're trying to capture the range of populations that exist in the area, including ideally those informal settlements. So in Worldpop, this is the kind of bespoke models we've developed with countries recently. Example here, just to show in Nigeria, expanding that one where from that northern Nigeria example, samples were taken across the country and used to produce these predictions with uncertainty around those. And then a similar thing in DR Congo, where that approach of selecting samples that tried to account for the range of populations that existed in the cities was used to produce those predictions. This is showing Kinshasa. So just to finish up, I think over the years, we've seen lots of improvements in our ability to capture population density variations in cities. We're capturing more and more of those really high density populations, as well as the remote low density populations. But they really are only as good as their inputs. So when you think about the population data, does it actually cover the range of variations that exist in a city? Is it actually capturing those populations that you want to measure and map? The covariates, do they enable sufficient characterization of informal settlements? And the models themselves, can they utilize these multiple forms of data that may help us characterize those informal settlements better? And can those model relationships vary by region, city? We don't expect every informal settlement to have the same relationship between its structures and its population. And so efforts to map and characterize those informal settlements, like Ideatlas, I'm hopefully hearing about next, can, I think, fill a vital gap here. And just to say, yeah, all the things I presented, there are various training materials, tutorials for these types of methods. I'm happy to share these slides afterwards. So thank you. We don't hear you.
Hello. Yep.
Hi, Andrew. Thank you so much.
Sorry.
Really appreciate your work. Incredible wealth of information there. Thank you so much for sharing with us. And I have remember everybody that we have notes in Miro, and the chat. I have the element that the link that allows you to go there and add notes and questions for Andrew for the roundtable. And with that, I wanted to introduce our next speaker, Ryan Vargas Mareto. Professor Mareto is an assistant professor at the Faculty of Geoinformation Science and Earth Observation, ITC, of the University of Twente. With a background in computer science and remote sensing, his main expertise is the application of deep learning, machine learning, data mining, and other pattern recognition methods to geospatial data. Mareto's research focuses on the development of AI-based models to automatically produce maps, combining geospatial data of multiple types and natures. His main research line has been on developing automatic methods for mapping, deforestation, monitoring the natural vegetation, mapping urban areas, and other applications. As software engineer, participated in the development of important open source geospatial platforms like Terra Live Library, the GIS TerraView, Terra ME, Terra Modeling Environment, and GeoDMA, and the framework of DeepGeo. Ryan Vargas, thank you so much for being here.
Thank you, Rota. I'm sorry, I didn't know if I had to start that moment or if you would start first. So, okay, let me just share the screen here. Oh, can you see the slides?
Yes.
Okay, 1 second. Okay, thank you everyone for being here. I will present for you the project we have been working on along the past year. It's called the Ideatlas, on developing AI-based methods for mapping and characterizing informal settlements from Earth observation data. So, oh yeah, okay. The screen, I lost a little bit the control of the slide, sorry. So basically, our team, this is our team. The PIs of the project are Dr. Monica Kufer and Professor Claudio Persello. And the main hands behind the code that generated the results I will present to you today are Pedro Tarecki and Paulo Silva Filho. They are also here with us today, but asked me if I could present for them. So I would like to leave a big thank you for them for all their efforts on developing those models and giving us these nice results. So basically, the idea behind the project is to develop, implement, validate, and showcase some advanced AI-based methods for mapping and characterize the slums, for providing some more information for achieving the indicator 1111 from the SDGs, and based on that, we are proposing to produce 3 types of products. The first one is to map the extent and temporal dynamics of informal settlements from 2019 to 2023. And the idea is to use cost-benefit analysis and data from different remote sensing products and produce annual maps from the SLAM extent, accuracy assessment, and also assess that together with our co-anchors and local actors on how, not only how we can improve those maps, but how can those maps be useful for local communities, local governments, and so on. So the idea is to produce that in an user-centered approach where we are interacting constantly with our co-anchors, trying to not only improving the products, but also improving how can we produce useful information for them. So the second product is some indicators of the slum severities for the cities that have been mapped. So these indicators will be developed based on a list of indicators and features like income, access to infrastructures, access to services like education, health, and so on. And based on that, we want to develop a deprivation model that will generate for the whole extent of the cities an estimation of how deprived those areas are, what is the level of deprivation, and also kind of a probability of deprivation for each of those areas. And the third product is the city scale indicators, where we are estimating the population living in the private areas, and like what's the amount of population, and several indications on the level of the city, on the scale of the city. And those indicators will be derived from the previous 2 products as well. So basically, we selected 8 cities across the world. Those are the cities indicated in this map. And the idea is to generate the most transferable model possible, where we could use maybe, if not the same model for all the cities, the closest possible for all the cities, trying to map as much as possible them in the same way. So this could give us a subsidy to further develop a worldwide model in the future. And basically, the methodology is based on fully convolutional networks. Those are nowadays some of the best models based on neural networks for automatic mapping, object detection, and so on, for pattern recognition in general. So the idea is to combine Sentinel-1 and Sentinel-2. Those are freely available SAR and optical data, respectively. And for most of the cities, we are getting also very high resolution images, where we are testing the models and comparing also with the models from Sentinel-2 and 1 to see what are the differences, what are the potentialities of the free data compared to the data with the very high resolution images. And also these images are used for validation, are used for checking, and so on. Also combining with ancillary data, population density maps, and so on. So basically, some of the experimental results that we have developed, and also the computational environment that we are developing there, the whole model on the cloud, on the platform, a platform called CrioDias. This is a platform provided by Cloudferro in a collaboration also with the European Space Agency. So they give us access not only for computational structure, but also the whole data from Copernicus is available through this platform. So we have all the data, processing units, everything in the same space, making the processing much faster and much more efficient. So basically, the deep learning model that has been used is a lighter version of the UNet. The UNet is it has been considered already a very traditional deep learning method for semantic segmentation and automatic mapping in remote sensing. And the idea is we developed here a fusion block that combines Sentinel-1 features extracted from Sentinel-1 and features extracted from Sentinel-2 and analyze them together in a way that can produce map taking advantage of the texture features and the optical features from both different types of data. So here are some examples of Sentinel images and worldview images from the same area. So we are also testing the methods on, we have worldview images for most of the city. Some of them we have some aerial mapping or other types of very high resolution images. And the idea is we test the models on worldview and then we test again also in Sentinel and compare the results and see what is the added value from each of them. Also, we are using some morphometric features extracted from the building footprints. And the idea is to extract features like the building densities, building orientations, and several others. Then we are doing that in two ways. The first is extracting the features directly from the building footprints and using that as an auxiliary data from the neural network. The second way, we are trying to make the network to estimate itself these features from the images. So the building densities, the building orientation, and so on, they enter as a ground truth for a second ground truth for the image, for the network, and the network estimates before the final classification. The network estimates these feature densities, these morphometric features, and from that, together with the other features extracted from the image, it performs the classification. Then some of the results that we have here for Nairobi, we performed the classification on Sentinel-2 and on worldview. And despite the results were a bit better for worldview only, we will show later that Sentinel has also a lot of potential for the mapping, because despite the very high resolution images, they bring more detailed information, but they bring also a lot of noises together. So also then the best results that we achieved were in the combination of Sentinel-2 and the density features, and also using together Sentinel-1. So here some of the examples here. As I mentioned in the previous slide, you can see that the delineation in some parts here for the very high resolution is a little bit better. However, it brings also a lot of noises together in some other areas that confuses the neural networks. And then when we use a lower resolution, looks like the network manages to capture a little bit better the larger scale context of the areas and perform a better mapping of those areas. Some other examples here, and also in the product validation. So we are trying to collect as much as possible the adequate number of testing data and samples for comparing with the ground truth and also for visual analysis. Because as I will show, like I will show later, we have a few inconsistencies in our ground truths that are not because of lack of quality, but because they were developed for another purpose. And also computation of seed level accuracies and metrics, like I showed before. Also, we are quantifying and calibrating the uncertainties of the prediction based on different metrics derived from the neural network uncertainties, like this one shown here, for example. And also we are performing some comparison together with the co-anchors, where we send the data for them. If they know the area, they are sending for us information. If they don't know, they are going to the field and checking the information for us. And that, especially that part, generated some very interesting cases for us. Like, for example, these cases in Buenos Aires. These two areas, they were not in our ground truth and as informal areas, but our algorithm mapped these as informal settlements. And then we sent the data for our local co-anchors there. When they went to the field, they discovered that there were actually some informal areas there that were then added to their databases, because these areas were not registered in their databases yet. Another example also from Nairobi, that also this small pocket was also not in our ground truth, but the model detected that as an informal area. And when our co-anchors came to the field, they identified that it is indeed a small market, a small pocket slum there, with characteristics of deprivation. And this other area also that was detected like as a false negative by our algorithm. It was actually in the ground truth as the private area, but when they went to the field, they identified that this area indeed is not a deprived area. It's a pocket of non-deprived area among the rest of this deprived area. So also some of the challenges that we have, as I mentioned it before, some noises inherent from the data that we have. Here we have some examples from Salvador, where the problem here is most of those polygons that we are using as ground truth, they were not developed with the purpose of mapping formal areas, but with the purpose of planing the census. And then we have the information of the deprivation on each of those polygons that we call the census districts. And each of those polygons have the information of deprivation that we are using for training the algorithm. But then, for example, some areas of vegetation or some areas of that combine a little bit of deprivation and not deprived areas, they are together inside the same polygons because of these characteristics of the data. And when we run the algorithm, we are managing also to map quite well these areas, and these have generated some interesting results as well. And here also another challenge is in the imbalance between data, because for most of the pattern recognition algorithms, the more imbalanced is the data, the highest will be the challenge, because imbalanced data tends to generate biases in your training, which means your algorithm tends to become more specialized in the classes where you have more samples, and less specialized in the class where you have less samples. And then you need to use tricks also for performing the balancing of that through the loss function or through other tricks like data augmentation and other things like that. And so this is another challenge in that we are facing for improving the quality of the models. So yeah, I hope I didn't explode much the time, and this is what I had to present for you today. Thank you very much.
Thank you, Ryan. That was wonderful to hear. Thank you so much also for being cognizant of time. That was really easy to follow too. So with this, we move to our next. Sorry. Sure. With this, we move to the roundtable. We have a few talking points that we want to all to start trying to address. What kind of informal settlement is slum-related data do we most need and why? The opportunities and challenges related to the availability of EO data, and what approach, tool, etc. works well in the context of scalability and transferability. I think there's some questions that are in the minds of all of us. We have a set of RT experts that will help us to maintain the discussion alive. Claudio Ascioli from Housing and Urban Development Specialist, Stefano Georgianos from Karlstad University, Binti Singh from KRBIA from Mumbai, India, Brian Ekstrom, GM, United States, Mariana Belgiu, ITC, Danielle Lufer, ACC, Reynaldo Paul Perez Machado from the University of Sao Paulo. And I apologize for butchering all your names as part of this. And so I will be moderating the questions, so please raise your hand, and we will try to have the discussion alive. Also remember that we could be using questions that arise on the Miro board as a ways to continue with the discussion. And with that, maybe Stefanos would like to start with the first set of questions of our roundtable.
Yes, sure, absolutely. It's nice to be here, and yeah, thank you for the very nice presentations. And my background is in remote sensing, urban geography, and to an extent, informal settlement mapping. So particularly with the second presentation, it was, and from a global perspective, it was a very good example of why we don't have any global informal settlement products available, because it is an extremely challenging, very difficult task to do. We more or less, I would have to say, or I would like to think, we have the data, the remote sensing data, and we have very good building footprints that are getting improved year after year. We have a lot of spatial information. We have good resolution, openly accessible Sentinel, for example, data that are able to detect urban morphology. But what we don't have to a good extent is the local data. If, for example, we look at the satellite image and we ask all people present here, can you map informal settlements? It will probably get as many different answers to that as participants. So we need local knowledge. We need contacts with the community so we can bridge this, both of the sides together and get something good. At the same time, most of the research is found in primary cities, and you raised the topic before as well that we need to go into secondary cities, and we need more work there. So to start maybe with some questions to Professor Mareto first, and continuing with what was in the comments, one would be regarding the in situ data. What are your sources and how much are they in quantity, let's say? How much do you need to get good results, and how much do you think this is going to be, let's say, a challenge or an opportunity for the Ideatlas project?
Thank you very much. In our case, Stefan, we are using mostly Google Building Footprint, and also I think Microsoft Building Footprint as well. And basically, of course, these data are not perfect. We can find some buildings missing and so on, but as you saw in the results, for the purpose we are using, it's improving a lot the result. But on the other hand, I agree with you for the lack of local data, and I think this is the most challenging part for several reasons. the first one is the privacy of the communities as well. One of the reasons that this data is not easy to find is because the more you make it public, the more you can put in some areas the communities under risks of eviction, risks of attacks, and so on. So there is also a balance that needs to be achieved, especially in certain countries, on how publicly available this data should be, and so on. And I think this is one of the things that makes the tasks of mapping quite challenging as well. And on the other hand, about the point that you mentioned of the, like, if you ask for everyone, if we could map slums, we would have many answers. And true, because also every city, every place, every country has a different concept of what is a slum, what is a deprived area as well. So whenever you are mapping some features, first you need to come to a definition of what that feature is. And in this case specifically, it's even harder because it's a concept that varies from place to place. So I think, I don't know if I replied the whole question, but I think this is the main point.
Yes, thank you. Thank you very much. I think it was a very informative. And what regard, let's say, assuming you have the final outputs, let's say the informal settlements or deprivation, would you, continuing on the privacy comment, would you put them publicly available, or you would share them with trusted stakeholders and organizations, for instance?
Yeah, in the case of our project, we have discussed it in some living labs and workshops with communities and local stakeholders. And this is something that varies from city to city. In some cities, they have told us that the more detailed we share the data, the better it is for everyone. In some cities, they were like, hey, you cannot share this data because you can put the communities in risk of eviction. So our idea here is to maybe create in our system some different levels of access for different types of users, where for some cities, maybe most of the stakeholders can access the whole data, but for the cities, especially the cities where this data is more sensitive, we can give access to the full resolution for the most trustable stakeholders, the stakeholders that will make a good use of that data, and make publicly available some probability surfaces or a lower resolution data, or even some fuzzy borders, so we could reduce the risks for the communities as well. So we are going to tackle the sharing of this data more or less in that direction.
Okay, thanks.
Thank you, Ryan.
Thank you.
And Ryan Engstrom has a question. Please, the floor is yours.
Hey, thank you, Yoda, and thank you, Brian and Andy, with these presentations. It's been a long time. I've done a lot of the population stuff and trying to do this slum stuff for a long time. And just a few points, I think you're talking about, the difference is how do people define it? And it's really difficult when you're going after this tiny minority class and everybody's defining it differently. And so there's so much uncertainty in this. So like, how do you start to even validate it or make a prediction? So my question was like, how accurate do we need to get? And, and how much, like you talk about the privacy of this, like how small of a unit do we even want to try to get to? And so this is kind of the things I think we need to think about, like, if people are making decisions on the data we create, like how accurate does it need to be, and how representative do we need to pick up every little slum within it? And then how does that feed back onto the population estimates that Andy's doing, like in terms of making his predictions? If like he doesn't even know the population in some of these slums, like, and when you look at our models, like the extremes, the tails are always what constrain it. And so when you don't have any estimate of how dense it is, or the number of people living there, like how much do we improve his models going forward, and then how accurate do we need to get when we're making these predictions? And these are some of the questions I've been struggling with. And the last thing with transferability, the question about that, we've been testing it and it seems to transfer between some cities, like Accra and Nairobi could kind of transfer, the models kind of work, but Lagos is very different. And so how do we start to understand how these different city morphologies and what are the driving forces for our ability to model transfer between cities? And these are kind of the discussion I'm interested to see what your guys' thoughts are on these things.
Thank you very much, Ryan. Andrew, do you prefer to start yourself, or shall I start? How do you prefer?
I can just a quick comments, I guess. Yeah, I think. Hi, Ryan. Good to see you again. I think it depends what you want to use these data for and who's using them. And yeah, our aim is to try and get as accurate as possible a population estimate for these grid cells for a specific time point, and trying to capture those variations that exist across the world for that, I guess, that first slide I showed, to be able to give small area population estimates, particularly in the cases where there are very outdated estimates or no estimates that anyone trusts at all. And so, yeah, I think some of the work that we've been doing with Dana Thompson and some of the work that she's led in terms of actually identifying areas that people pretty much agree are informal settlements, measuring the population in those, the densities, and then comparing against how well we do. All of the gridded population data sets, we don't do very well. We're not capturing those extremes. And so that's where I think, yeah, I was in my slides trying to make the case that, yeah, having data where we can identify, oh, we pretty much agree this is an informal settlement, and we can get some population estimate, whether it's just a small sample to say in this kind of area, can we identify those types of areas, and can we get a sample of the population density? If we can have that, then the models have something to work with, and we can get a population estimate that's a bit more reliable and captures those really low and really high population density areas that we're still not doing so well on. So yeah, over to you, Ryan.
Thank you, Andy. Ryan, thank you very much for the question, and very nice to see you. And yeah, in our case, this part, we are basically trying to get as much as possible the concepts and the most accurate data from the stakeholders, from the local stakeholders. And in terms of granularity, the idea is to tackle that with Sentinel resolution, 10 meters. But also, as I mentioned, for some cities, we might share on lower resolution or even just a surface probability. And in terms of the transferability, indeed, I think this is the biggest challenge. And for now, we are training the models city by city, but we have the idea of trying to test the transfer learning by pre-training the model in one city and refining the training in another cities as well. I think in terms of transferability, this is the main thing we are trying to do for now. We plan to make some tests by just training one city and applying in another city as well. But I think we need some refinement of the training. Just applying the weights from one city to another, I'm not sure if it would work well. But by refining the training on other cities, and later on, also, I think one possibility would be by making a big training data set composed of all the cities and try to see what comes out of that. I think this has potential as well, but will make the task a little bit more complex.
Thank you, Ryan and Andrew. Claudio, do you have a question? The floor is yours.
Yeah, thank you. Rather than a question, is more than a comment, and I want to congratulate everyone who have made the presentation. And Anthony asked me to bring some perspectives of practitioners and from what do we do and what can the data and all the effort that you do provide for those who are actually working in slum upgrading or citywide slum upgrading or settlement improvements. So I come from let's say from a generation that worked from the settlement mapping using different kinds of remote sense data, including aerial photography, but actually going to the ground, doing enumerations, identifying the locations. So the importance of knowing the reality is fundamental if you're talking about the intervention. So as we move towards citywide, then the kind of demand of data and information changed radically, not only about the level of infrastructure, but total population, location vis-a-vis, different kinds of, let's say, features like risk areas, prone areas. So the geography of these areas in the cities where they are contexts. And then during my time in UN Habitat, then the scale went up to world and national, because the dialogue about the slum data and the reporting that UN Habitat were responsible for the NGOs, you know, the 7-11, improving 100 million slum dwellers. So it was important to get the city data, because most of the data coming from city, but most important because the dialogue was the national government to have the aggregate data on the national level to report on the MDGs, at the same time to make, which create a lot of controversies, who were progressing well and who were not progressing well in realizing the MDG 711. Now that was very interesting because colleagues from the Global Urban Observatory, they were looking at what was called housing deprivations, and then looking in the same city using some of the data type of instruments you were showing, you know, GIS, remote sensing, satellite data analysis, and then going to the ground with field research to actually showcase to different governments that in the same city you have different types of slums where, you know, the housing deprivation could be, yeah, you didn't have water or you didn't have sanitation, but you actually had security of tenure, you know, the 5 dimensions of the slum definition. And so to conclude, I think that it is super interesting what you guys are attempting to do, you know, using different technologies, methodologies to actually be able to get a sense what the reality in the cities vis-a-vis, you know, the slum population is, or informal settlements. Some countries prefer nowadays not to use the denomination slums. But I think we need to keep in mind that what is that we need for what purpose? And I think this is a fundamental question. It is interesting to investigate the global picture, but in the end of the day, we need to really go down to the territory where public policies are making a difference and needs data to provide evidence-based interventions. And I think that we should never lose track or lose sight that in the end is what do we do with that for the purpose of improving the quality of life of those people who live there. And I think that, you know, when you look recently, some years back, when SDI started training the women to use GPS and actually make their maps, and making that campaign of, you know your city. So actually mapping all, you know, single housing, where they live, who lives there, etc., became a very powerful instrument to negotiate with the local governments about improvement in their areas, but also to negotiate the issue of security of tenure. So I think I stop here, and I think the fundamental question for me when I saw your presentation, I always bring back to me, you know, does this help me to actually transform the life of those who live there on the ground in the cities? And I think we should never lose sight of that. Thank you.
Thank you, Claudio. Do Andy or anybody else would like to answer that? Or Ryan?
Yeah,
I know it's a difficult question to answer.
I know.
But yeah.
It's maybe, yeah, I guess it's more of a comment, and the same, I agree with the comment. And I think where we have seen our population data sets and models actually used by governments and in health campaigns, in censuses and official statistics and education is where we have engaged with those governments and decision makers right from the very start, that they have approached either a UN agency working with us or ourselves and had a very clear use case and be able to co-develop that solution with them, designed specifically for that use case, so that there is full understanding throughout. They can argue to their superiors, they can argue to the public about why these kind of approaches are needed and what's involved in them. And then, yeah, that's rather than us producing an output and putting it on the internet and hoping somebody will use it. That's very rarely the case that actually gets used for changing people's lives. So yeah, I completely agreed. Thanks.
I move to our next question. Mariana, you have the floor.
Thank you so much. I'm not sure whether it's a question or a comment, but I would like to go back to Ryan's comment on transferability. I was working, and I'm still working quite a lot on improving the transferability of machine learning / deep learning for agriculture applications. And then I moved also to slum mapping. And what we realized during our work is that there was a lot of focus on two questions mainly: how to transfer and what to transfer, but there was not a lot of focus on where to transfer to. And Ryan was mentioning that if we want to improve the transferability, and during their work, it seems like they found that some models are more transferable across certain cities. I think the first step that we need to do is to find ways to assess automatically, if it's possible, the similarity between different urban areas, so that we first answer the question where to transfer to. I don't know whether somebody has experience with this or not. And I think the second comment is related to what one of Andrew's keywords, co-creation. Together with Monica Kufer and our PhD student, we are working now on developing data-centric AI solutions to try to map slum. What does it mean? It means that instead of focusing on improving or fine-tuning some of the model parameters, we try to improve data availability and data quality. And with data quality, we also want to be sure that we represent the perspectives of different users on their reality. So we do want to be sure that the perspectives or the definitions of local communities on what a slum is captured by the training sample sets that we are using to train our model. So I think my question is whether, so what would be the comments on this idea of involving users or developing data-centric AI solutions for slum mapping, and whether this would be a solution also to improve the transferability of the existing AI models. Yeah.
Thank you, Mariana. Ryan, do you want to answer that, or anybody else of the panel would like to answer some of this?
Actually, at least in my point of view, I think one of the main things that applying that for slum mapping could help on improving the whole thing of transferability is the fact that it's a very, very challenging task. And sometimes even visually, you cannot identify that. So, and also the fact that the concept varies so much from city to city, and varies so much from country to country, and sometimes even from city to city inside the same country. For example, in Brazil, if you go to Rio de Janeiro or São Paulo, the characteristics of the slums are completely different from one city to another. So I think in terms talking about the method itself, being such a challenging task could help us to move forward in the techniques of transferability as well. I don't know if I answered that. Yeah.
Thank you. I think that's a question in everybody's mind, and trying to figure out that it's going to be the next challenge for the entire group of researchers here. So I want to give the space to Reynaldo to ask a question.
Hello, everybody. Thank you very much for the opportunity of being here and to listen to this panel, which is very, very important from my point of view. I come from a classic cartography, remote sensing, and GIS teaching for many years, but also very interested in slum mapping for many years as well. I make my part of my graduate studies in UTC many years ago, in 1990. So I'm old guy here, but I was about to lower my hand. Actually, let me do that. Especially when Claudio actually was speaking, because his speech was very much coincident with what I would like to say. So I am not going to repeat. But again, it's more an observation than a question. But I think that given the suggestions you prepare for this panel, I am going to focus first on the first and second. What kind of informal settlement do we need and why, and the opportunity and challenges. So I think from my point of view, these are critical in this analysis. So I think it's evident that the high resolution imagery, it is available not so, quite recently, if compared with medium resolution imagery. So I think one of the big challenges of these studies of slum identification and mapping and studies and projections is precisely in the possibility of integrating several sources. So many of our colleagues here have mentioned that, but I want to stress the point that especially medium resolution like Landsat is of increased value of analysis, especially if we wanted to find something that might be applicable to most different environments. This is also a contradiction if we mention the last things that we hear here regarding how different can be these informal settlements in different parts of the world, even in the same country or in the same city. Somebody mentioned the city of São Paulo. The city of São Paulo, we have different kind of slums, in different geographies, let's say, in lowlands which are swamps or something like that, or in very dangerous slopes. So I think that in the old times, what we call ancillary data. So that is also a challenge to be able to gather information reliable, especially for the possibility to know or to study, for example, the population density in these slums. Some years ago, I participated in a study where we, with Professor Chris Small, where he presented a panorama of how it was the verticalization we found in several slums here in the city of São Paulo. So I end here. I just wanted to point that from my point of view, the most big challenge of you guys is to cope with all these sources and all these resolutions and try to, it will be a dream, I think, to find some characteristics that will be somehow measurable for all different part of slums in different countries or in different places of the world. Thank you very much.
Thank you, Reynaldo. Who wants to take this question? I guess Reynaldo's question was extremely difficult for our panelists.
I can just say, yeah, it's another one where I think we all agree that this is we agree it's a really hard challenge, and that there is not one type of slum that exists everywhere. Even within cities, there's great variation, and that makes it really hard. And it means that we have to think about methods, as you said, that can cope with multiple types of data that can try and characterize those differences, particularly when we're on our side, when we're thinking of estimating those populations. We cannot assume that if we find a slum area that we have population data for, and that relationship holds for an informal settlement the other side of a city. So the more data we can have to characterize those relationships in terms of how does population relate to the different characteristics of the settlements across urban areas, the better those models are going to be. And yeah, we have to then balance that against what's the data actually needed for, and what's it going to be used for. And in some cases, it doesn't need to be very fine scale. It needs to be at an aggregate level, or it needs to just differentiate between different areas of a city to prioritize an intervention. So it's that balance between the variations and the needs and the data that we have. That's me getting out of the question by just saying it depends.
Thank you, Andrew. And I think it's a very challenging one. I'll move to our next question. Sanjana, can you please add your question? I'm sorry to butcher your name.
No, that's fine. Hi, I'm Sanjana. I am a PhD candidate at the University of Kentucky, and I'm currently in Mumbai for my fieldwork. I apologize, I'm unable to switch on my camera right now. It's night and I do not have privacy, but I just wanted to get to my question, which was like, my research is about how the government is using technologies in the governance of informal settlements in Mumbai. And I came across an interesting case, like where the urban local body in Mumbai is basically using high resolution satellite images to compare the growth of informal settlements. Every 6 months, they'll take images of it measure the growth and basically use that as evidence for the demolition of slums. So it is unlike what a lot of you are doing. It is used for a pretty against people and their right to housing in the city. So the question that I is something someone asked previously about how accurate can such technologies even get? Because the government claims that it can be as accurate up to a few inches, but how precise accurate can it be? If it is imprecise, how many houses, for example, are we talking about, right? And like to what extent should or could remote sensing be used in such manner as evidence for driving decisions such as demolishing houses? Yeah, that's.
Well, that's quite interesting, these two levels between, kind of the ethical aspect of it versus the availability of the data and how others are using that, and sort of the negative aspects of using remote sensing. Ryan, Andrew, do you want to answer that? I think we have touched a little bit on this question, but I think that this is more precise into the point of almost ethics of it.
Yeah, I think the first point of that, I would say, it's usually I like to rephrase this question more in terms of instead of how fine you can do that, to how fine you should do that, how fine you need that, because okay, for several, we have nowadays available images on 30 centimeters like world view, but in several cases it ends up bringing more noisy for the mapping, or like you are spending a lot of money in images that you don't need. If 10 meters you can solve the problem. So also I think the ethical issues are also quite a big issue nowadays as well, because of risks, especially in this topic of the slum mapping, because of putting the communities in risk of eviction, having their houses demolished or put on fire or attacked in some ways. So yeah, usually whenever we are defining the granularity on that is also, I think the question more important than how fine you can do that is how fine you need that, I would say. I don't know if this answers the question or just raises one more.
Yeah, just to add to this, I think this idea that we are not the ones setting up the scale. The scale is set up by the providers of data, and who use it. It depends on the values and ethics of each one of those, and those are so readily available that I think that now we start seeing ways in which could use in other different ways. That is not what we sort of like with this group is intending. And so it's interesting to formulate those questions as we move forward. Julio, you wanted to answer to that?
Actually, I want to ask a question, if it's possible.
So I wanted to give the space for Ryan that wanted to answer some of the previous question, and so I would like to, and then you could go next. Ryan, the floor is yours.
Yeah, I just wanted to say, the complexity and the variability within cities and all these differences, they're all there. If it was easy to do, we would have already done it. And that's kind of been the whole challenge of this, is the more you start looking at the details and the variability within this, it gets more difficult. One of the things we've talked about, like trying to expand these models, is trying to map urban morphologies, and then do we have similar urban morphologies in different cities, and use that for a guide for us to make predictions in different areas. And you saw some of the stuff that Andy was putting up where like they know there's residential areas and commercial areas. Like if we can just reduce that to just residential areas, okay, and that reduces the amount of area we need to process, because like Rayan is saying, there's a lot of noise in these data sets. And so you start training a model, and what we find is anytime we put in a little touch of vegetation, it starts mapping every piece of vegetation as deprived. And so it makes it very difficult to make these predictions. And this is where we got to start thinking about our training and validation data, and then the urban morphologies that we're trying to map in, and trying to, you know, pan these cities. And then are these cities, is there similar urban morphologies that we see in these different cities? Can we use these building footprints to go after this type of stuff? And this is some of the things we've been thinking about going forward. And the question that Anna put up of, like, you know, feedback on these models, and this is something that's been, I think, highly lacking in all of these models, is we produce a model output, but we don't talk to the people on the ground and then get them to feedback and help us. And that's what we're trying to do in some of the idea maps project, is put out, here's our estimate, and then you guys tell us where we're right, where we're wrong, and try to feedback and figuring out what we're missing. Because we can't do this all through EO, because deprivation, like lacking water, we can't see that from a satellite. Or, you know, all we can see is the tops of buildings and the structure and orientation of them. We can't see inside the building. And so we're never going to get to that point. But what other data sets can we pull in to improve that? But these are some of the things that can answer some of these questions that we're discussing right now.
Thank you. That was really important. The floor is yours.
Okay, so it's just a very simple question. I don't want to miss the opportunity of having Ryan and Andrew here at the same time. So I've been working with a lot of urban mapping in large scale, spatial and temporal scale in Brazil. And one of the things that we ask ourselves very often is, where is the point to decide it's time to use a deep learning model, or we can keep using a more simple model like random forest or different approach in machine learning, because it's costly when you move from a classical deep learning model to a more advanced deep learning model like UNet, and this one that Ryan is presenting. And I'm asking it because how good a slum mapping needs to be in order to be useful to the planners and to the people that know the territory. Because if I change for deep learning, I cannot, it did not grow so much in terms of scalability, for example, because it's costly, it's much more time for training, etc. And so how good a slum mapping needs to be, and where is the point that I'm sure that I have to decide, okay, it's time to use deep learning that you are doing now. Ryan, thank you.
Yeah, I think that's quite tricky, because like indeed the complexity grows quite a lot, and but from the geographic part of the point of view, or from the city's point of view, I cannot answer that much. I'm more a guy from the method itself. I'm not very much from the geography or from the process itself. But I would say, like, nowadays there are a lot of researchers trying to reduce the computational cost of deep learning. And in that sense, the job that Pedro and Paulo did in this way was quite interesting, that they managed to reduce the complexity of the UNet, keeping a very interesting accuracy. But also in the computer vision community, there are a lot of work on how we can, because the deep learning started like, okay, let's put everything together, let's grow, and whatever you put together, let's do that to improve the accuracy. And now there is, since a few years ago, there is a movement in the computer vision community on trying to reduce that, because when you increase too much the network, you increase a lot the number of redundancies on the features it extracts as well. So now there are several research lines on trying to reduce the computational cost of that by trying to analyze the filters, trying to analyze the features, and reduce the complexity of the computational complexity of that, keeping the accuracy. I would say, if you want to go for deep learning this and want to scale up for a big scale, I would say this is the way. But yeah, in terms of the decision level, I don't know how to answer the question. Like, I would say more from the point of view of the method itself. I don't know if Andy or any other can add on this point, but in terms of accuracy required, I would say the best you can do. I don't know.
I'm not sure I can
Again,
add, I'm not sure I can add much
go,
more.
go. Go.
Well, if I may add something, I think it's a matter of asking the question, the fit for purpose, sorry, the fit for purpose question. So, and this refers not only to the data set and the level of details that we want to extract from the level of the details of the information we want to produce, and this is fit for purpose when it comes to the produced data set. But the same question can be asked also fit for purpose for the model. If we know that the deep learning or a specific network outperforms all the other models that exist out there, especially in a very complex situation, then maybe we need to make some efforts to move towards that. But if the traditional machine learning, you mentioned, Julia, random forest, if this is something that serves our purpose, then we don't need to move to deep learning. So I think it's a very tricky question, right? And it's also a matter of the availability of training samples. It depends on where you want to apply that model, because if you want to apply the model in a region where you don't have a lot of training samples, then deep learning is history by default, unless we make efforts to increase the training sample set. So I think the answer to this, it depends. I think it's a fit for purpose question applied to both data and to the model.
And I think that Mariana's point also attaches to Claudio's position at the beginning, the most meta question, like why we're doing this. And so that I think is a beautiful way to wrap up our RT table. Thank you everybody for participating. I want to pitch in again the Miro board. If you want to ask questions directly to panelists or to connect with others in this space. And with that, I wanted to give the space for Anthony to do our closing remarks.
Well, thank you very much, Kotta. We're a little bit over the time. Thank you all for staying that long. I think we always have too little time to discuss. But what is very clear is that it's important that different sectors are more and more trying to engage with each other, and that's also one of the reasons we are organizing this Thinkers Campus. Particularly very obvious, like decision makers or people that have a strong experience to work with the government, etc., and more the practice-oriented research on GIS mapping of informal settlements. Here, there needs much more communication because it is a very tricky field that touches ethics, abuse of data, etc. So I think more needs to be done. We have submitted an application to the Swiss National Science Foundation, which we are crossing the fingers that it will get accepted. It would allow another possibility to bring people that this time physically together to discuss the topic. And we are also we mixed also the participants to have also more the political scientists, climate change, health related research, a lot of domains that touch informal settlements, their growth, and the kind of data we want to generate. Focusing on this series, this was the last event, so we are coming to a close. We will write a report. It will be, as always, then submitted to the Thinkers Campus and be accessible. We have also recorded all our webinars and make them available. So I've put already the information in the chat, but everyone who has been registered will also receive an email as soon as it is ready. We also would like to draw your attention to an event that is very similar, organized by UNITAC, SDI, Namibian University, and the African Center for Cities, I think, in Namibia on GIS, informal settlement, etc. It's taking place today and the next 2 days, so feel free to register and engage in more debates. This being said, we had really engaging webinars. We had great presentations. It's really rare to see such deep insights in very relevant initiatives, and we learned a lot. It was really amazing. I'm not a GIS expert, but I see the potential. I see like the developments and want to learn more. And for me, it was like a great experience too, from a more political science perspective, to see what is going on. And I hope we keep this discussion running. So thank you very much for all the presenters in our series, for the audience, for engaged debates, and looking forward for another Urban Thinkers Campus maybe next year on a related topic on informal settlements. Thank you very much.
Thank you, everybody.